Hi, in this video we're going to look at linear equations of two variables. First off, let's start with the definition. A linear equation of two variables, it's an equation and that can be written in this form. Ax plus by equals c. Now the x and the y are the variables, a, b, and c are constants. And that's just a typical notational thing. Letters near the end of the alphabet are typically used to represent variables, and lowercase letters at the beginning of the alphabet are usually used to represent constants. So the a, b, and the c are just numbers, x and y are the variables. This particular form, where we have ax plus by, so the terms with the variables on one side and the constant c that is without a variable on the other side, is said to be in standard form. Okay, we're going to be interested in finding values for x and y, that is, ordered pairs x and y, that when plugged into this equation make the equation true. Finding all of these would be finding the solution set. The solution set will be the set of all points that will, if we graph them, form a line in the xy plane. So a linear equation of two variables represents, or its graph would represent, a line. Okay, so ax plus by equals c, that's a linear equation of two variables. Here we have some equations, and let's identify which ones are linear, and if they are, we'll write them in standard form. So let's start with the first one. Here we have x minus y, all divided by 2, minus 7 times y, divided by 3 equals 5. All right, so here we're looking at the variables, and you can see that none of them are being raised to a power. They're all to the first power. There is an x and there is a variable y. So this is a linear equation of two variables. So we'll go ahead and write yes, it is. All right, and now we need to write it in standard form. And that means this form. So we need to get the constant on one side, everything with an x and a y on the left-hand side. Looks like we have the start of that, but we have y's in two places. We need to combine those. All right. The first thing that I notice here is that we have fractions. And I don't like fractions. Nobody really likes fractions. We can, though, if we have an equation, we can get rid of those by multiplying both sides by the least common denominator. So the first fraction here has a denominator of 2. The second one has a denominator of 3. So the least common denominator would be 6. So multiply both sides by 6. So this is here times 6, and 5 times 6. All right. We need to distribute this 6 into this difference. So 6 divided by 2 is 3. So we need to take 3 times this x minus y. We have to distribute into that too. So we'll have 3x minus 3y. And then 6 divided by 3 is 2. So we have 2 times 7, which is 14, so minus 14y equals 5 times 6 is 30. All right, and now all we have to do is take negative 3y minus 14y is negative 17y. So we have 3x minus 17y equals 30. So there is the standard form for this equation. The a would be the a would be 3, and the b would be negative 17. C would be 30. Okay, let's look at the next one. So we have 7x minus the quantity 4x minus 2, and then plus y, equal to y plus 3 times the quantity x minus 1. All right, again, if we look through this equation, we look at every term, we see there's no x raised to a power other than 1, neither for a y. You have to check these products here. There's no, so we multiply that 3, and that does not increase the power on x. That's just a 3. This minus sign here, there's no x involved with that, so there's no distributing here. Okay, and so now I will say yes again, is indeed a linear equation. And now we want to put it in standard form. So again, that means we need to combine all the like terms, get the constants without the variables on the right-hand side, the terms with an x and a y on the left-hand side. All right. So there's a lot of parentheses, there's a lot of multiplication going on. So let's go ahead and distribute and do it with what we can here at the beginning. So we have 7x minus 4x plus 2 plus y equals y plus 3x minus 3. Right, so the 3 times x and the 3 times negative 1. Okay, we can combine some of these on the left-hand side. We've got 7x minus 4x is 3x. Plus 2 plus y equals y plus 3x minus 3. All right, we'll subtract 3x. We'll subtract y. And subtract the 2, I guess. So it's like everything on the left-hand side cancels out. On the right-hand side, we have minus 5. Now, of course, 0 does not equal minus 5, so this is false, of course. And that means that this equation is a contradiction. So we have to go back and change our initial statement here. This is a contradiction, and so it is not a linear equation of two variables. All right. Let's look at the last two. So here we have 3 minus 2x squared and the x squared right there. That is enough to say it is not a linear equation of two variables. So no, right off the bat. The second one, we can see that as well. We've got x squared to start out with. X squared is not a linear. We can also see that here we have the quantity x minus 1 squared. If we were to FOIL that out, the very first term in the FOIL first, we take x times x and get x squared. This is not a linear equation of two variables. Okay, next up we're going to look at lines and the forms of lines and slope, everything to do with that, and we'll even graph some. So stay tuned for that.